Anchor is another popular model interpretation technique and has been invented by the same set of researchers who have invented LIME. An anchor basically addresses one of the key shortcomings we have seen for LIME model interpretation. So LIME basically proxies the local behavior of a model in a linear way. And LIME use linear regression model to find out feature weights, and using those feature weights will explain the model outcome. But it's not clear to what extent those explanations made by LIME holds in a region around the instance. So take an example here. So here you can see that in order to explain any instance at this point, right, LIME has used this linear regression model, right? But if we'll go slightly up at this point, right, probably LIME will not be able to provide a clear explanation, and probably it will give the incorrect judgment of the outcome, right? Because here clearly we can see that it's positive, and using this linear regression model, probably it will say that it's negative, right? Because at this point we can clearly see that it's dividing the space between positive and negative, at least for this instance, right? And not for the other instance which are very near to the instance which we are explaining with the help of LIME. So that's the problem we have with LIME model interpretation, and which can lead to the overconfidence in the explanation, and probably it will give misleading conclusion on the unseen but similar data. Okay, so like we have seen that if we take any instance at this point of time, right, it will give incorrect conclusion about the outcome. Okay, and anchor address all those shortcomings with the help of anchor formulation. So anchor is nothing but it's a set of feature conditions which will help us to explain the observation of interest. So in this case, my observation of interest would be this point, right? Observation of interest, and it will also explain the observation around those points, right? So to take this example, so the dotted line explains about the anchor, right? So it's a set of feature conditions which will define this anchor, and anchor will not only explain this model instance, right, which we are seeing here, but it will also explain all the observations which will fall in this region, right? So that's the beauty of anchor. So it will not only ensure that it would be able to provide correct explanation to the observation of interest, but it will also provide correct explanation to the surrounding observation with high precision, right? So that's why we call anchors are high precision explainer, which internally use reinforcement learning for deciding which features we need to include as a part of anchors, right? So it's nothing but it's a set of if-else conditions, right? So it has very robust mechanism in terms of finding out those feature conditions, and it has two parameters which will help you in deciding how much confident this anchor is. One is precision and the second one is coverage, and we will see the interpretation of those two terms in the demo example. Okay, so in summary, anchor is nothing but it's a set of conditions which are self-sufficient to explain the model outcome with high precision. Okay, so now we'll tackle one problem statement and we'll use anchor model interpretation technique to understand what are the different feature conditions my anchor interpretation technique provides, and what's the precision and coverage that provides. Okay, so let's start. So here we are simply importing all the packages required for model training and anchor model interpretation. So you can see that it's a set of packages for data analysis, then set of packages for machine learning, and then we have added few packages for anchor model interpretation. So you need to install anchor, right? Pip install anchor. It will install the anchor in your environment, and from that library you need to import anchor table explainer. It's similar to line table explainer, right? So I will just execute it, run it, and now we'll load data. So here I'm using credit risk data set. Load the data. So it contains 32,000 samples and 12 features. So we'll simply run it. Okay. And now we will build a simple feature transformation pipeline. So it's a very simple transformation pipeline, nothing very complex. So here I am defining all the numerical columns, right, which I will be using for model training, and I am defining all the categorical features, right, and here we are simply adding both numerical and categorical features, which will provide a full set of features which I will be using for model training. Then I am simply splitting the data set, and next I am creating a categorical index list which will contain the column index for my categorical column, and this categorical index list would be used by anchor model interpretation, and we'll see in this demo how we can use this list. And next I'm defining one dictionary which will contain uh, the index of my categorical column, and the value would be all the unique value for my categorical values, right? So these two values my anchor model interpretation technique will use for all the categorical features. Okay, and here we are simply doing a feature label encoding for all the categorical column, right, and nothing fancy. It's very simple label encoding techniques, right? So that's it, we are done, and now we'll train a simple XGBoost classifier. Now that's done, and when we will evaluate it against training and validation data, and you can see that training accuracy is 95.95 and validation is 93.61, and similarly for the AOC you can compare it. So we have used default parameters. I mean, it's very basic setup for XGBoost model. We are not optimizing it for better performance, but here I am just showcasing how we can use a very complex model. So in this case it's XGBoost, and how we can make a prediction against unseen data, and how we will explain the model decision made by XGBoost model with the help of anchor model interpretation technique. Okay, so here I am simply finding out all the indexes for non-default and default loan, right, and down the line we will be using those indexes for explaining default and non-default instances. Okay, so now here we need to initialize the anchor table explainer, right? So here first I'm defining the predict function. So predict function will take the XGBoost classifier which I have trained here, CLF, right? So CLF dot predict proba, and it will take the instance which we would like to explain, right? So predict function, and here I am defining all the feature names. Okay, so table explainer will take the value as classes. So here I'm defining the classes as 0 and 1, right, and the feature names. So all the feature value which my model has used for model training, so that's what we are providing it here. Then we need to provide all the data values. So here I'm providing entire training data, right, and here I'm providing the categorical name dictionary which we had created initially here, right, this one. So once that is done, we'll simply run this statement, and this will create an explainer. Okay, and now we'll use this explainer to explain the model output, and here I'm simply predicting. So prediction done by my XGBoost model is prediction is 0. And now we'll try to understand why XGBoost model has made this prediction as 0. We'll try to understand the explanation done by XGBoost with the help of anchor model interpretation technique. Okay. So here I'm simply taking the value as it is from my data so that we can compare what feature condition it qualifies. Okay. And here I am simply using explainer.explain instance, right? And I'm passing the validation data, in this case index, and this index will contain the index of my non-default. Non-default means 0, class 0. Okay. And I'm passing the predict function. So in this case, clf.predict function. So xgboost.predict, I'm passing it. And I'm passing another parameter called threshold. Okay. So we'll explain what it means, 95. And that's it. And once you will run this statement, and this will provide the anchor condition. So here you can see that the anchor condition is based on 2 feature values. And what it is saying that whenever my loan grade equal to B and the person income is greater than this amount, the explanation done by anchor model interpretation would be 99% correct. Right? So that's the meaning of precision. And coverage means the prediction done against the neighborhood of the data instance, right? So 8% of the neighborhood examples would be explained with the help of this anchor conditions. That's the meaning of coverage. Okay. And here we are defining the threshold as 95%. So which means that I am telling anchor model explainer to provide me all set of anchor conditions which are 99% confident, 95% confident in explaining the model output. Okay, so that's the meaning of threshold. Now we'll take another example for default. So here I'm simply running it, and you can see that prediction outcome is 1. And now we'll explain the model outcome. We'll simply run it, and we'll see what anchor outcome it provides and what's the precision and coverage it will have, right? So you can see these anchor conditions. So here what it is saying that the loan percent income ratio should be greater than 0.25, and if person home ownership is rent and person income is less than this amount, then the explanation done by anchor model interpretation would be 67% correct, right? So that's the meaning of precision here. And it will only cover 7% of the data instance around the observation which we are trying to explain with the help of anchor explainer, right? So it has given the minimum set of anchor condition. Definitely it's not meeting the threshold requirement which we have given here, but yes, the precision 67% means it would be true 67% of the time. And it may be due to data imbalance, because in this data we have lots of non-default data and we have very less instance of default examples, right? So that's why we are seeing the precision very low, right? So these are very powerful techniques, right? And using these set of anchor condition, we can explain the model output very easily with any person, right? In layman terms. Now we have seen that how powerful anchor model interpretation technique is, and it has several advantages as compared to other model interpretation technique. So like LIME. As we have seen that LIME works on the linear regression model, and it tries to find out the complex model decision with the help of linear models, right? But that's not the case, because We cannot say that the local data set or the model decision boundary would always follow the linear pattern. And that's the advantages we have with respect to anchor interpretation technique. Anchor use reinforcement learning to find out the different feature predicates, right? And it tries to find out decision boundary with the help of those conditions. Okay, so that's the another advantage we have. The other advantage anchor provides is around the feature conditioning, and you can see that it's very easy to explain those conditions to any person in a very simple terms, right? So you can see that it's a very user friendly way to understand how model has predicted certain outcome. Okay, and it's also very fast to find out the explanation of my model output. Okay, the main drawback of anchor model interpretation technique is around the number of predicates, right? So as you can see that as the number of predicates will increase, explanation would be very much specific to that observation, and in that case the coverage will definitely go down, because once my anchor condition would be overly specific to explain any particular instance, that condition will not be able to explain the instance near that observation of interest, right? So which is not a good case always, because there might be the case that some value will deviate slightly from the observation of interest, and if my explanation will deviate too much, then that's not a good sign for any interpretation technique, because in that case model explanation would be unstable. So that's it for now. Thanks for watching it.